So we're going to try some sampling of our own, and this is something that I do in class with my students. Unfortunately, you're online, so I don't have M&Ms to share with you, but maybe, you can go get chocolate out of your cupboard if you get hungry while we're doing this. But so the interesting thing about M&Ms is that there is an actual distribution of how many of each color are produced every year. And this is the actual breakdown. So we have 20% are orange, 13% are red, 14% are yellow, and so on. The M&M's company has published this information. These are how many of each color are made. So we can think of all of the M&Ms made in a year as the population. Let's think of every possible M&M out there. I can draw a sample of those M&Ms by getting one of those bite-sized containers, right? So this is a sample of M&Ms, and I'm going to look and see how it stacks up against the population of M&Ms in terms of the colors. So in this case, our sample has 13% red, 20% blue, yada, yada, yada. And I'll pull up the numbers from the population again. And as you can see, our red is straight on, exactly. Our blue is off just a little bit. Our yellow is off a little bit, our orange is directly on, our brown is off, and our green is off. So when we draw a sample, it's never going to be exactly like the population, but we hope it's close to the population. So would you say that this sample is close to the population? Well, in some ways it is, in some ways it isn't. But when it isn't close to the population, we can say, well, this is a very small sample. So we can expect that there's going to be idiosyncrasies when we draw a small sample. Let's take a look at another sample, shall we? Okay, here's another sample. This is an actual sample that I opened up today. And if we look at this is really off. I mean, the red is 33% in this sample, but it's only 13% in the population. I mean, pretty much across the board. Look at brown. There's not even a brown in there. So this sample is very strangely drawn. It's not very representative of the population, but yet again, it's a pretty small sample. So let's look at one more. This is the third sample I drew today. And some of them are close and some of them aren't, and it doesn't really look like it fits all together that well, but again, it's a small sample. So what's going to happen if we combine 10 samples? So I took those last 3 samples and I added 7 more samples to them. Now let's take a look at the breakdown and see what the percentages are. Oh my gosh, we're getting pretty close on a lot of them now. We're still off on a couple of them. We still pretty much have a small sample when it comes right down to it, but red is pretty close to the population and yellow is very close, orange is spot on, and green is right there. So we have a little bit of imbalance in our blue and our brown. But what would happen if we then combine 20 samples? With the larger number of M&Ms that we pull, the more close our sample will be to the population. So if we keep drawing, if I take out 10 more and I rip them open, those numbers are going to really start to flesh out and become more like the population. So we can draw a sample to do our research, but we have to keep in mind that if our sample is small, we may have some idiosyncrasies. We want to pull enough numbers in our sample to kind of flesh out some of these random error problems. Does that make sense?